Okay, chapter 4 on probability. So probability, last week we were looking at experiment, output and sample space, the Venn diagram, the tree diagram. Alright, then we were looking at how to do the calculation. The calculation include multiplicative rule and involve permutation, circular permutations, and combinations. Alright, then I think we should start here, right? Calculating probability. Am I right? Let me see. I think so because I've forgotten to put down. Yeah, okay. Calculating probability. So what is the probability? Probability is a measure of the likelihood that the specific event will occur. How likely it will occur. Okay, it will happen. Then, remember we have simple event. What is the meaning of simple event? With only one outcome, right? With only one outcome, one and only one outcome. So, probability of EI, where EI is a simple event, is called P bracket EI, is the probability that a simple event will occur. Alright? But if I have a compound event, normally compound event will put it as capital letter A, not only A, can be A, B, C, and so on. Anything, but normally it's capital letter. EI is a very specific one. That is for simple event. Okay? Then the property will be the probability must be from 0 to 1, and when you sum all the probability of the simple event, it should go back to 1. Okay, so we have three conceptual approach to probability. How to count probability? The first one, classical probability. So classical probability is look at the set. So when you have a set, alright, set A, and you have NA, small letter n with a bracket A means how many elements in the set A. Alright? The number of elements in set A divided by the number of elements divided by of the sample space, everything. So, or we say this is n, small letter n divided by capital letter N. Where small letter is always like the sample size and the capital is the population size, right? But here, actually, it refers to the number of elements in the event divided by the number of elements in the sample space, where is all. Where that's all, right? Now, example 4.11 is a very typical example. A fair dog is drawn. Fair. Fair means what? Fair, very important. So what does it mean by fair? Means, what happened to the probability? No bias. Same. Alright, so they are equal. So they are equally likely. So when they are equally likely, when you have a down drawn, right, that means what is my sample space? What is my sample space? What could you get? You could be 1, 2, 3, 4, 5, 6. Alright, and probability of getting a 1 or any one of them is 1/6 because equally likely. Alright, but now my event A is the number is odd. So what is my event A? Odd. Odd is 1, 3, 5. 1, 3, 5. So you see, whenever we talk about the event, in the classical way, we put into a set form. Then we follow all the rules of the set. What do I mean rules? You have, this is what? No. No. This is subset. This is, you do discrete max this semester, basic max. No. So this is element of. Then this is subset. Then this is intersect. Intersect means n. Intersect is n. Then this is all. All is union. Okay. So now if that's the case, what is my probability of A? 1/2, it comes from 3/6 because I have 3 elements. So that's the meaning of NA. How many elements in A divided by how many elements in S? I have 3 divided by 6. Then yes, you need to put it as 1/2. Number-wise, it need to be that way. Okay? Then what about B? The number is greater than 4. What number are greater than 4? 5 and 6. So probability of B become 1/3 come from 2/6. Alright, so you need to put it that way, not the final answer alone. So now, since this is not related, I just want to know what is A intersect B? 5 alone, this is set. 5 alone, that's the meaning of N. Is in A and in B. So what is A union B? 1, 3, 5, 6. Because this is in A or in B also also included. Okay? Okay? Element of is like, I would say, 3 is in A. Sorry, it's supposed to be in A. But 3 not in B. Alright, there's no subset here. Okay? Revision a bit. Then the second method is relative frequency concept of probability. So now, when we want to find the probability that the next baby born in the hospital is a girl, then we cannot use the classical because I don't have all the baby yet because it's the next. You find that or not? The next one is a girl. What's the probability? So, how do you know 0.5? No, we didn't know. Okay, so now, this one I cannot use the classical. I want to tell here is I cannot get the classical. Now, the tossing of an unbalanced coin. will result in a hat. Unbalanced. If this is fair or balanced, then I know to get a hat is half-half. But this is not balanced. How do I find the probability? Okay, now for your actual science, that is always asking the probability that an 80-year-old person will live for at least 1 more year. Because that will affect the premium of an insurance if this old man want to buy an insurance. But that will affect the claim. Alright, so that's why we always need to know this. This is before the person dies, is it? We want to know whether he will live for another year. Okay? So we cannot use a classical rule to use to find the probability. So how can we do that? Want to find the probability, then we must perform the experiment again and again or from the past history. From the past history, then we can find the relative frequency. You remember in your chapter 2, you learned relative frequency, right? So therefore, by using relative frequency, we can make it as an approximation of the probability. So therefore, this is F over N, is the frequency divided by the total. But now, you may say, can it be correct? Yes. This is done by a law called law of large number. Law of large number say, if an experiment is repeated again and again, the probability of an event obtained from the relative frequency approaches the actual or the theoretical probability. Okay? The key is this one. You need to repeat again and again. You cannot take one sample and decide on the probability. Okay? Like you know the coin is not balanced. How do I know what is the probability of getting a hat? Okay? And I toss 2 times, 3 times, definitely no. You may need to toss like at least 100, 200 or 1,000 times. Sometimes we believe that you need to do it like 10,000 times or more. Okay, especially nowadays with the big data issue, right? The sample size is getting bigger and bigger to get the probability. Okay, so now, okay, come back to this example 4.12. A survey of 350 families gave the following data on the number of children under 16 in each family. So we found that 185 have no children under 16, 51 has 1, 90 has 2, and 24 have 3 or more. Now find the probability that A is a household selected has no children. So what is the probability of A? The probability that a household selected has no children. So that is 185 divided by 350, right? So that is 37 over 70. Okay. Now, event B, I have a household selected has at least 1 children. What is the probability for B? Okay, is because at least 1 include what? 1, 2, is it at least 1? 3 or more? So I can either sum all these 3 or I say this is 1 minus probability of A. So that become 33/70. Okay. Is it always like that? What happened? I more again, then she say, what happened to you? Okay. Hello. Then another one is a subjective probability. So it's the probability assigned to an event based on judgment. Okay? So it's based on subjective judgment. Somebody thinks that, experience, information and belief. So now, example will be, what is the probability and that Carol who take a statistics course will earn an A in this course? So this one is, it depends on what's the history of her subject taken, right? Maybe. Then what happened to our Dow Jones Industrial Average? Will it be higher end of the day or end of the next trading day? Okay, so we can find the probability. Okay, what about the probability that Joe will lose the lawsuit that he filed against his landlord? All right, so all this probability is very subjective. So people will tell you chances is very low or chances is very high. Okay, so now that is the three classical approach. It's not what we have nowadays. Okay, we have a lot of machine learning idea, but come out after that. This is a classical approach. Okay, so the next thing is probability and combination analysis. All right. In most of the probability problems, we need to determine the number of possible outcomes in the sample space and the event. So then this will involve permutation and combination, right? We talked about that before. Now, example 4.13. I have 5 cards are drawn from a deck of 52 well-shuffled cards. Find the probability that 4 cards are aces. How can I get 4 aces? I have 52 cards, 4/52. What do you think? But what we try to, yeah, actually, you can go back and think about that. But we can think about it in a more specific way is, what is the NS? What are the possible outcomes? How many possible outcomes if I take 5 cards from 52 cards? I have 52 cards, I randomly draw 5. How many possible outcomes? I give you hint already what? P5, C5. So this is 52, C5. Then how can I I get 4 aces? So all 4 aces, I get 4. Then 52, 4 aces. Because it's aces, then how many not aces? 48. So 48, you choose how many? C1. Okay, only this one I want you to count. Can you count this? Your calculator, please. Divide already, You divide already, Cannot be more than 1, right?
Like 1/4, 1/5, 1/4.
Count again. Count again. What do you get?
5414.
Oh, you all get your calculator like that one,
No.
I want this.
Oh, yes.
I want to show this only. The purpose is this. My purpose is to want to show you this. That's why I say only this one I want you to count. You should get 1.85. In your calculator, you see something like -5 there, right? Is times 10 to the power of -5. This is the standard form. Okay? So now, when this is standard form, what does it mean?
Percentage is
0 point, how many 0? 4, 0, then 1, 8, 5. That's my purpose. I want to show you this one only. So you can keep this answer, don't worry. Okay? Now, what happened to B? 4 aces and 1 king. What's the chances? 4C4 and 4C1 over 52C5. Okay, then what about this? 3 are tens and 2 are jacks. Then how can I get 3 tens? 4C3 jacks 4C2 then over 52C5. Okay, what is the probability of getting 9, 10, jack, queen, king? 4C1. May I know what is 4C1? No, what is the value for 4C1? 4. Because you have 4, right? Then your chances of getting any one of these is 1, 2, 3, 4, right? That's why 4C1 is always 4. NC1 is always N, right? NC0. What is NC0? 1. Because you are N and you choose nothing, there's only one A. Empty, nothing. Okay? But how to find the probability? We have many ways. Okay? So now, we start with all the classical method. Then you want to advance to future, all more advanced method in the future, right? That one later on you will study. No worry. Then now, the next thing is marginal and conditional. Marginal probability is the probability of a single event. Single event. One thing only. We talk about one thing. Probability of getting ahead. Okay? So, one thing only. And without consideration of any other. Marginal also we call this a simple probability. Okay? Then conditional probability is the probability that an event will occur given that another event has already occurred. This one, you need to be careful on your languages. Okay? Now I have two events A and B. I have two events A and B. Then the conditional probability of A given B. This is A given B. Alright? Now please write carefully. Probability of A given B. The given is a straight, not sliding. Not like that, huh? So it's straight. So it is say, if we read, we say this is probability of A given that B has already occurred. Okay? So now, the formula will be, what is the probability of B given A? B given A happened already is probability of A intersect B divided by probability of A. Okay? Given at the back, that is divide the one. So if A given B, then is probability of A and B divide by probability of B. Okay, A and B given B, so divide by probability of B. Divide by probability of B means now probability of B is the whole thing. Okay, we look at this, then hopefully you know better. Yeah, given that these two cannot be zero, because zero you cannot divide already, right? So now let's look at this. I give you, yes, simple example. You try to relate this to your tutorial. Can I double check? Where is your tutorial already? Yeah, where? 3 already, right? So this week we still have tutorial 3, right? So can finish, right? Okay. Now, the following is a two-way classification table. Now, this style of table, we call this a two-way classification of responses of 100 researchers, whether they are in favor or against genetic engineering. So they will ask, you are okay or not okay with this genetic engineering? I put it this way. In favor is event B, against. Against means not agree is A. Then M is for the researcher is a male, then this is a female. Now, I hope you understand this thoroughly. Then when you do conditional and marginal later, every time it will be more easier than to you. Now, when I have one researcher is selected at random, can we find the probability that the selected researcher is a male? A is a male. The someone is a male. Is it one event? One event only, right? Then this is probability of male. Male, I put it as M. Alright? Now, when I'm talking about male, so I'm asking on everybody here, then I'm looking for a male. You understand? So I have all together how many people? So I have all together 100. Then out of 100, how many are male? 60, because this one is a male, this one is a male. So when I sum these two, I have 60. So therefore, this is 60. Okay? So you look at this again. I'm now checking the male, one of the condition, male. I take care of whether this is in favor or against or not. No, right? I'm looking for the male only. Male alone. So that's why I'm looking at this part. Now, second one. I'm looking for the probability that the researcher is in favor of genetic engineering. In favor of. In favor is B, right? And that is one single event only. So for B, I'm looking for probability of A. Is that okay? Am I right? A alone. A alone, right? So sorry, is a B, right? In favor is B. B alone, sorry. So B alone, how can I look for B? Am I taking care of male or female? No, right? This is altogether 19 over 100. Okay, so now, this is not here, it's supposed to be at the back. So since we are here, then we talk about this also. Now, what about 15? What happened to these 15 people? What happened to these 15 people? These 15 people are male and they are in favor of genetic engineering, right? Hello? They are male and in favor, right? So male and in favor 15 is out of everybody, am I right? So therefore I can say 15 over 100 is probability of what? So it's male and in favor. What is N just now? Intersection. Okay? Then what about 36 over 100? Female and against. So that is N. So remember why N is this person selected, it must be female and at the same time against, right? N compared to everyone. My N is compared to everyone. Is that okay? Okay, so now you are very clear. What is N? What is single? Or simple or marginal? This is marginal. This is joint. So we are joint probability later. But I just do it here. Okay? So now let's look at this. What happened to this? Probability that the researcher selected is against to genetic engineering, given that this researcher is a female. Given that this researcher is a female. So when I know this is female, I take care of who? Female only, right? Should I take care of the male? No, I don't look at the male at all. You get me? So that is the given that. So now, yes, notation wise, then you should know. See, I'm looking for probability of given that this is a female. Given that this is a female, and what is the probability? The probability that the researcher is against to genetic engineering, so it's A, given is a female. So when I have this, given is a female, so what is my total? I have all together 40 only. I don't have 100. I have 40 only. And out of 40, how many against? 36. You get it? You see the difference? When we have given that, that means we have restricted population. We restrict to female here. Okay? Can understand? Okay, make sure you understand. Then please do your tutorial. Okay, we go back to the number later. Now, what about the last one? We go the other way around. What is the probability that the researcher is a male, given that this researcher is in favor of genetic engineering? So may I know its probability of what? M given B. So M given B, what's the probability? (15/19), because B altogether we have 19. Out of 19, 15 are male. Okay? Yeah, then we go back to this. This is 9/10, and this is how many? 3/5. Then these two cannot be simplified already, right? Okay? Can understand, right? Yeah, then go back to your tutorial. Do it, then only you will remember better. Okay. Then after we have this type of probability, then the next thing is you want to know what is mutually exclusive event. Mutually exclusive events are the events that cannot happen together. They cannot happen together. Okay? So this is one of the simplest event, the simplest example. That is, I have lowering of a dog. Okay? So A is an even number observed. So what is even number? 2, 4, 6. Then what about B? 1, 3, 5. Okay. Then what about C? 1, 2, 3, 4. Include 5? No, less than 5, we don't include 5. Then the question arises. Events A and B mutually exclusive. How can I tell they cannot happen together? Okay, so that means I must find what? A intersect B, that is empty set, right? Empty set can be like that, right? Okay, so up to you, but I'm more common with the second one actually. So it's empty. So therefore, A and B are mutually exclusive. Okay, the next one are event A and C mutually exclusive. Why? Then you must find A intersect C. A intersect C, what we get? 2 and 4. Is it empty? No, this is not empty. So this part becomes important. It is not empty. So therefore, A and C are not mutually exclusive. Okay? Okay, so now, check and see your attendance okay or not. Anyone has problem with attendance, please come and meet me as soon as possible. Don't wait until the end. Okay? Okay, sorry. Let's have a break until 12. Uh, but before that, may I check with you is who's in line around? Who's in line? No. Okay. I didn't check.
Can I use this formula instead? Means got different condition lah. I don't want because last time we learned we don't use n+1, we just use n over 4.
This one for group data.
And this one they use for ungroup data.
No.
The condition it will get the same answer. If r is an integer, you take that number and then the next one. So if 5 then x5 plus x6 divided. It's applicable for all case 1. It's just that I'm used to this formula. I try for all the tutorial question, it will get the same answer as your method, but then I'm just more familiar with this one.
I think about this. Let me write down. If correct, then no issue. N divided by 4.
Because if you use n+1, you get the decimal, then it's like very, very complicated.
n plus 1 divided by 2, you get integer. Integer is odd. Let's say integer, I really go back and think about it. This one from where one?
During my STPM, my lecturer teacher is she also mentioned the n plus 1 formula, but she said that this one is more easy to understand.
Nearest integer. Nearest following integer
So
or nearest integer?
Round up, meaning round up.
Always round up lah.
Always round up.
Okay, so that could be good. Thank you.
So,
I think about that later.
So I check back with you later.
Later because they are rushing me something.
It's okay. Thank you.
I'm not sure. You go and bring another table. It will be better. You don't have table before this,
It's okay, like we just want to sit more closely with you because we get used to it.
Okay. Okay, the next thing is we have two events. The two events are said to be independent. Okay. So now when we have two events, the two events are said to be independent if the occurrence of one does not affect the probability of the occurrence of the other one. then we say they are independent. So now, that means like this one. How do we say this sentence? We can say probability of A when you know B or you do not know B are the same. This one is when you know B first. This one is do not know. So when you know B or you do not know B first, they will be the same. So, we can say in formula is probability of A given B is the same as probability of A. Okay? But in fact it means you give given B first or not given B first, they are the same. Okay? So this one the same, probability of B given A is the same as probability of B. Students always make mistake. The common mistake is they do probability of A given B, they compare with the probability of B. Is it correct? No, then this is definitely wrong. Okay, because what we want is the other way around. Okay, so now, if they are independent, then this happens. If not, then they become dependent. So, the two events are dependent if either A given B is not the same as A or B given A is not the same as B. Okay, now, what happened to this? I have a box of 100 CDs. Okay, then it was produced by two machines. Machine A and machine B, one or two, and they are defective or they are good. Defective means they have problems. Okay, so good means they are okay. So now I want to know D and A, are they independent? Now D and A are they independent? So now let's say I'm looking for probability of D given A. What is probability of D given A? Count D given A is what? 9. This is A and D, right? 9 over 60. Because A we have all together 60. Then I must compare with what? Probability of D. So probability of D is 15 over 100. This is 0.15. Is this 0.15? So then this is the same as probability of D given A. Okay? Now I can then say A and D are independent. Then another thing that very common mistake is actually they are not the same. Actually it's not the same. Like probability of D given A is actually 0.149. Then we put this is 0.15, so they are the same. So sorry, don't round up, not simply round up. Okay? So not to simply round up. Okay, so then this is wrong. Don't simply round up. Okay? Then please make sure you decide or conclude D and A are independent. Okay? Okay, so now, two important observations about this mutually exclusive, independent, and dependent. So now, when we have two events, they are either mutually exclusive or independent. Okay, either one actually. So, mutually exclusive events are always dependent. Is it correct? Now, I see. Now, when I have A intersect B is an empty set, what is my probability of A intersect B? 0, because nothing, right? So they are mutually exclusive, then the probability must be 0. Then what about probability of A intersect C? 2/6 or 1/3, which is not 0. That's why they are not mutually exclusive. Alright? So now, when you have an event, or two events, they are mutually exclusive. They are mutually exclusive, then the probability of A intersect B must be 0. Okay, and one more thing later, we know that if A and B are independent, then probability of A intersect B must be the same as probability of A times probability of B. So when you times two positive events, how can I get a 0? One of them need to be 0, then you multiply only you can get 0, right? Okay, so that's why it's either this happen or this happen. If they are independent, then they are not mutually exclusive. Okay, so because you have this multiplication of these two positive, multiply of two positive, you should get positive. You don't get 0. Okay, but now dependent event. Dependent means when they are not independent, so it could be mutually exclusive, it could be not mutually exclusive, because this is may or may not be mutually exclusive. Okay? Okay, now, the next thing is complementary. Complementary event. The complement of event A, denoted by A bar, I think in the notes I put A bar, or AC. Complement is the event that include all the outcome for an event, for an experiment, they are not in A. So normally this one, we call this event as not A. We call this as not A, not in A, so not A. Okay, so probability of A plus probability of not A always be 1. Those in A plus those not in A, so it will be everything. Okay, then 4.17, in a group of 2,000 taxpayers, 400 has been audited by ISR at least once. If one taxpayer is randomly selected, what are the complementary event? So what is the complementary event and the respective probability? Okay? So if I let A be the event that a selected taxpayer has been audited, then what is the complement? Is the event that the selected taxpayer has not been audited. Alright? So this one has been audited is the A, then the complement must be the one has not been audited. Now, please bear in mind, because I don't want you to copy in the lecture, that's why I type it out. Okay? If this question is asked, then you must write down what is the complement and what is the A. What is the A? You must let A be the event that the selected taxpayer has been audited. You can cut short, but not, the main thing is still be there. That means you can put down let A be that selected taxpayer has been audited. Okay? Then A bar is selected taxpayer has not been audited. Okay, just that I don't want you to copy in the class only. It doesn't mean I will do it for you all the time. Sometimes yes, but not all the time. Okay? So now, the next question is, what is the respective probability? I actually looking for probability of not A. So what is the probability of not A? Or actually, is either 1 minus 400 over 2000 correct? Or actually you can have like 2000 minus 400 divided by 2000. Either one will do. Is 4 over 5 or 0.8. Okay? So now, intersection of events and the multiplicative rule. Intersection of the events I let you know already. Let A and B be two events defined in the sample space. The intersection is a collection of all outcomes that are common to both A and B. So normally we say this is A and B. So that is A intersect B. Then when we are looking for probability of A intersect B, we call this a joint probability. Okay, together we call this a joint probability. Alright, just now we find the formula for A given B, right? But in fact, you need to remember only one of these. You see, it can also be written that way. Probability of A intersect B is probability of B given A, then times probability of A. So, if I'm to find probability of B given A, then isn't it this is probability of A intersect B divided by probability of A. Right? You just move this over, right? So to me, you need to remember only one. You don't need to remember all. Let's say I don't like this set, then you use the other set. Probability of A intersect B is probability of A given B multiplied with probability of B. This one follow this one. To me, this is easier to remember. Up to you. Up to you. Then when I want to find A given B, then I bring this over. Then it's probability of A and B divided by probability of B, right? Okay? Now, it says if there are two independent events. Remember, independent event, A given B and A are the same, right? So that's why you get this. B given A is the same as probability of B, right? Then it becomes probability of A times probability of B. Okay, so now I'll give you an example here. A box contains two DVDs. Four are defective. If two DVDs are selected at random without replacement, at random normally without replacement, what is the probability of both of them are defective? How you did that before? Let D be the selected DVD is defective, right? Then what is the probability of both are defective is defective, right? That become what's the answer? 20 DVDs, 4 are defective. 2 randomly selected DVDs are both defective. What's the probability? Four over 20 times 3 over 19. So then this is 3 over 95, correct? But now, there is nothing wrong with this. Nothing wrong, don't worry. Okay? Now, another proper way will be if I let DI be the I selected DVD is defective. I have selected 2, so I can be 1 or 2. Okay? So how can I have both are defective? What happened to my first one? How can I have both defective? Your answer is correct already, but then in a more formal way. Okay? Now, lecturing, studying, you are doing very formal way. Make sure you know all the basic. Unlike competition is the faster disease. No, we need in a proper way. How can you have 2 of them are defective? What happened to the first one? First one, is it good or defective? Very simple question here, right? When I have both of them defective, what happened to the first one? Is it good? Not good, right? The first one is defective lah. Then what happened to the second one? Also no good. So that means actually this probability in the proper way is probability is the first one is defective and the second one is defective. How can I have first one is defective and second one defective? It must be my first one is defective. My first one is defective, then when first one is defective, then second one is defective, right? The answer is the same, right? When I select the first one, then the first one could be defective or good, right? Okay, then only I choose the second one. The second one could be defective, could be good, right? If the first one is good, my second one also could be defective or good, right? Right? Then the first one is good. Sorry, defective is 4 over 20. Then good is 16 over 20, right? If the first one is defective, what is the probability of second one is defective? 3 over 19. What about good? 16 over 19. Then what about this? 4 over 19 and 15 over 19. So now, because this is first one, so I can call this a D1 and G1. Then this is D2 and G2, right? Because the second one. Now you see, when you do that, you are correct. That's why I say you are correct. When you are having probability of D1 and D2, it's actually probability of D1 times probability of D2 given D1. Because the first one is 4/20, the second one is 3/19. I don't say your answer is wrong. I just say it's very formal way. Okay, very formal way should be like that. Because if the second one is defective, the second one, this one also defective. But if I'm looking for the second one is defective, but when my first one is good, then this is 4/19. This is not 3/19. You get it? Not only to know how to count. Okay? So you ask me if in the test, the final, you give me this one. Is that okay or not? I'm okay, don't worry. But then I need to let you know this is a proper way. When you want to go at once, you need to understand the scenario clearly. You get that? To me, teaching and learning is you need to understand as much as possible, not only to get the answer. Okay? Pro and set 1 basically very simple, but not pro and set 2. Okay, then. Okay. Okay, so we go back. Then this one, no different, is still 4/20 times 3/19. So then this is 3/95. I also hope that with this, you understand the conditional and the join better. Conditional and the join better. Okay? So now, so how are we going to write this? The probability that a patient is allergic to penicillin is 0.2. Suppose the penicillin is administered to 3 patients. Find the probability that all 3 are allergic to it. So now, if I let A be the patient is allergic to penicillin, okay? So now, what is 0.2? Sorry? Of? Allergic is what? Is A now. So you are supposed to say probability of A is 0.2. Okay? So now, if previously then when you have 3 patients is administered to the drug, alright, that they have taken this, so what's the probability all 3 are allergic to this? So I have probability of A, right? That's what you always do. So what's the probability of A? 0.2 times 0.2 times 0.2. So this is 0.008, correct? Okay? So now, how could I write this? in a very formal way. I could put it let AI be the eye patient is allergic to penicillin. Then probability of AI is 0.2, right? Where I is 1, 2, 3. I choose 3 only. Right? Then how can I have all 3? What happened to my first patient? Allergic or not allergic? Yes, right? Second one, and the third one. That's why this is N, because they happen together. And they are different patients. So when they are different patients, are they dependent or independent? Independent. So independent, so this is probability of A1 times probability of A2 times probability of A3. Because they are independent, they are different patients. So, yes, I get back the same thing, is 0.2 times 0.2 times 0.2. Then this is 0.08. Hey, one more zero, right? Okay, now let's say I give you extra question. What is the probability of the second patient is allergic to penicillin? That's why you have 0.8 times 0.2. Then why don't you just put it as what is the probability that the second patient is allergic to penicillin? No, what is this? Probability of second patient is allergic to penicillin. No. What P of what? A2. I already say probability of AI is 0.2 for I 1, 2, 3. Right? I'm asking actually is probability of A2 is 0.2. Okay? Then what about C, D or D? The probability that one of them is allergic to penicillin. So probability of one allergic, unless I put this as a B or C or else then I accept this. Probability of one allergic. How can you have one allergic? How can you? Not the answer. Not number. So you remember what is what, how, when, where, please be careful. How can I have one allergic? Can it be the first one? So that means it can be the first one allergic, but the second one allergic or not allergic? No, and the third one not allergic, or the first one not allergic, but the second one allergic, and the third one not allergic, because I have only one allergic. Or I'm having the first one not allergic, second one also not allergic, but the third one allergic. Am I right? Okay, so that's why sometimes you ask why I need to multiply by 3. This is the reason. When I have one allergy, it can be the first one, yes, but not the other, or the second one, but not the other, or the third one. So now, what is the first one? Probability for the first scenario. Okay, then the second one is 0.8 times 2 and 0.8. Okay, or okay, okay with that. Okay, so hopefully you understand independent, joint, and all better. Okay. Okay, so then what about B? Find the probability that at least one of them is not allergic. B. At least one not A. What is at least one not A? At least one means one not A or two not A or three not A. So what is the complement? So
Just 1 minus O is A.
So that means I have one not A, or two not A's, or three not A's, right? So what is the other events that could happen?
1 minus.
No, the other events means it could be none of them not A, right? So when none of them not A means all 3A, right? So that's why, yes, you are right. You can do 1 minus probability of all 3A. So it's 1 minus 0.008. So it's 0.992. Okay with that? Okay, so now, joint probability of mutually exclusive event, we talked about that already. If A and B are mutually exclusive, then probability of A and B is 0. Then union and the additional rule. So union is A or B, alright? Union is a collection of all outcomes that belongs to A or B or to both of them, so A or B. So additive rule for probability of A union B is probability of A plus probability of B minus probability of A intersect B. So if they are mutually exclusive, then you need to sum only these two, right? Then now if I have A, B. So now, if I have A, B, this is my A. And if I plus probability of B, this one I plus. So the middle one has been repeated. So that's why you need to minus. Alright? Because this one is counted twice already. You need to minus one of them. Okay? So now, example 4.20. So now let A be the event that a person has normotensive diastolic pressure, that is the DBP less than 90. So A is less than 90, B is borderline, so it's 90 to 95. Now, probability of A is 0.7, probability B is 0.1. Okay, now I want to find C. C is the person has a DBP less than 95. So it's like that. 90, less than 90 is A. Okay? 90 to 95 is B. Then what happened to C? C is less than 95. So what is C? C is less than 95, include A and B, right? So that is probability of A union B, or you just make it like probability of A plus probability of B, because there's no intersection. No intersection because this one no equal sign and this one with equal sign. We take care of that already. So then this is 0.7 plus 0.1. So this becomes 0.8. Okay? Okay? So now D, the event that the person has DBP more than equals to 90. More than equals to 90. More than equals to 90 is actually from 90 and above, right? Okay, so this is the complement of A, right? So it's 1 minus probability of A. So it's 1 minus 0.7. So it's 0.3. Okay? Then what about C? Two persons are randomly selected. Find the probability that at least one of them has DBP less than 90. Less than 90 was A, right? So I'm having probability of at least 1A. So at least 1A is 1A or 2A's. Right? Which one is not A? D is the one not A, right? So that means I'm having the complement, right? Both of them not A, right? At least one A, so it's a complement to this will be both of them not A. So that is 1 minus D is 0.3 times 0.3. So that is 0.91. Okay, so now, for the following data, what's the probability that a randomly selected person with multiple jobs is a male or a single? Okay, so now, very funny number so that you don't repeat the number, right? So now, I want male or single. So probability of male or single is A. What's the formula? Probability of M plus probability of A minus probability of M intersect A, right? So we need to find probability of M. What is probability of M? M is this one, right? So it's 4, 2, 3, 7, then over 7, 9, 5, 5, the total. Okay? Then, what is probability of A? Probability of A is this one, 3522 over 7955. Then, what about probability of M and A? M and A is the intersection, right? M and A is this part, and this thing is actually from the whole thing we look at how many are male and they are single. So it is 1562 over 7955, right? Okay, so then this becomes 4237 over 7955 plus 3522 over 7955 minus 1562 over 7955. Okay, so when you count, we get 6197 over 7955. Okay, so it's not good for us to start base rule. So we start that at 2. So we stop here today. This slot. I will meet you again at 2, right? So you need this.